Hello, everyone. Today is Wednesday, December 1st, and this is the Cluster API office hours. If you haven't joined us before, this is a reminder that we have a meeting etiquette. Please raise your hand if you'd like to speak. And if you have any topics you'd like to discuss, please add them to the agenda under today. If you haven't already, you can add your name to the attend list. And we'll get started with some PSAs. Fabrizio, take it away.
Thank you, Cecile. So hello, everyone. I try to keep this nice and short since we have two demos and we are all looking forward for them. So minor release planning. So we are planning to cut v1.1.0 sometime in the middle of January. But and we will start to cut the first RC release probably in the middle of December. Around the middle of December. And the PSA, the most important things here is that we are introducing cluster class, a lot of work done there. Stefan will give an update later. What we really need now is feedback from the provider, from the community. So we are looking forward for this stuff. And if someone from the provider needs help in getting started with cluster class, please reach out to me, to Stefan, or Kilian, Yuvaraji, to the team, so we can help and try to bring all the community using this feature. And I go on also with the next point, which is patch release planning. So in the last 2 or 3 weeks, we had a couple of fixes. Both in main and then they were backported on the different branches, and so probably sometime end of next week we will cut a series of patches release with all these fixes.
Awesome, thanks, Fabrizio. All right. Any other PSAs or any questions about the release planning? All right, if not, let's keep going. I'm not going to go over each proposal, but does anyone have updates on any of these or any proposal that's in progress that's not in here that should be in here, or anything that should not be in here anymore?
This is David Watson. I just have a quick comment on the load balancer provider. I'm not aware of much work occurring on that this half. It's something that I'm considering working on next half as part of my company's roadmap. So I'll just mention that I'm still interested in doing this, but I don't think that a lot has happened yet.
Okay, thanks for the update. Anyone else? All right, if not, let's keep going. All right, so let's get into the discussion topics. Paul and Cheyenne, you have the first one.
Yeah, thanks. So we just wanted to sort of say hi, because it's the first time that we've joined, just to let you guys know that we at Oracle are working on a provider for our cloud infrastructure. And it's just to sort of reach out and say that we're joining, being part of the community, and yeah, looking, we'll probably have some silly questions, but we'll probably be looking for some advice as we go forward. Really, we've got a couple of, I'm a product manager looking after our implementation of this, and we've also got Todd, Joe, and Cheyenne from engineering on the call as well. So this is just the first sort of step to say hello to everyone, really.
Awesome.
Yeah,
welcome.
Hi. We have some topics also. So we have a initial implementation which uses the image builder project as well as the cluster API. So we would like to understand what the next steps on how to create a repo in the Kubernetes 6 project, how to push stuff there, whether we can raise the PR for the image builder project and all those things.
I'll take the image builder part, and then Fabrizio, I'll let you maybe take the repo. For image builder, yeah, feel free to open a PR to add a new provider for image building. As long as it has like proper documentation and everything, you can find some example PRs of previous providers that have been added. It should be pretty straightforward.
Sure.
Fabrizio, do you want to answer the question about opening a provider repo or creating?
I'm passing to link to the meeting notes. So basically, the process for asking a repository depends on the fact if you are starting from an empty repository or if you are donating code. But I have passed the linked document. Please take a look. If something is not clear, we will put you in contact with the right people in CNCF with the legal team in CNCF if you need clarification. Okay. And once basically you are ready to do so, then it is just a matter to open an issue in Kubernetes.org. Typically, it is required that the SIG chairs, in this meeting we have Vince, but it will be nice if you show up at the SIG meeting. So we basically, you basically introduce yourself also to the rest of the SIG. Once the PR, the issue is there, Vince and the other leagues plus one, the issue that the repo gets created, and you are ready to go. So it's not difficult just after you sort out the problem about donating code.
Sure. Thanks. We'll look at this. Thank you.
Well, the other thing I'll add is there are a lot of other providers hanging out in the cluster API channel on Slack. So if you have any questions or anything, you can always post in Slack and get some good.
Yeah, we are already active in Slack. So yeah, thank you.
Awesome. Great. All right. Killian, go for it. Mission health checks proposal.
Hi. Yeah, so this proposal has been kicking around for a while. It's been quite dormant. But I just made some updates to it over the last couple of days. So this is about defining a machine health check inside a cluster class and then having the cluster class reconciler create that health check. So this is change to the cluster class API. Is really well documented here and a bit of the behavior and validation of it. So yeah, so I think all of the conversations are resolved. So if you had previously taken a look at this, I kind of spun a couple of conversations out into different issues and tried to make this kind of the minimal implementation so we can iterate on it later on. So anybody who can, please review this. It's a relatively small change, and particularly anybody who has any expertise on machine health checks and any experience using them today to make sure that this aligns with what people would expect in a cluster class implementation.
Thanks, Gillian. Any questions about this? All right. If not, let's keep going. And I think we have our first demo. So I will stop sharing screen. And Anusha, you can take it away. You should be able to share screen.
Thanks, Cecilia. Do you all see the presentation?
We see the meeting notes, your Edge window.
Oh, okay. Sorry, let me check. How about now?
Yeah, we see it.
Can you see it still?
Yep.
Okay, great. So hey everyone, I'm Anusha. I'm an engineer at VMware. So we have been working on a new provider called Bring Your Own Host, BYOH in short. So in this meeting, I want to introduce to you all what Bring Your Own Host provider is, why we started with it, and probably show you a small demo on how this works and where we are at currently. Now, this might seem a little familiar because just a few weeks ago, we had a demo from Cap Live by Twilio. So we have started a discussion with them on Slack, and we'll see how we can collaborate with them and see what are there any overlap between the two providers and how we can move forward. But right now, I want to just talk about BYOH. So why BYOH? So it started with a use case where we had to support Kubernetes on infrastructure like Hyper-V. So there was no cluster API provider for Hyper-V present. And then, so we thought bring your own host could be a good use case here. And also we plan on extending BYOH to bare metal possibly, because we have seen customer use cases as in where the customer wants to manage the host, the physical host and the operating system, and they want us to manage everything Kubernetes around it. So we think this could be a good potential use case for bare metal as well. Coming to like the current cluster API providers like vSphere or AWS, this is a typical cluster API provider. Like I'm not sure if all the providers work a similar way, but I'm sure most of the providers do. Suppose say whenever there is when you want to create a workload cluster or a cluster with say one control plane node or a one worker node, the cluster API controllers together with the provider controllers provision the hardware, as in suppose say we are creating a vSphere cluster, we have it creates vSphere VMs based on the different OVAs that are already available. So these OVAs have Kubernetes binaries baked into them. So all of these OVAs or AMIs that are built using Image Builder have Kubernetes pre-installed in them. And then we use the bootstrap providers like kubeadm to bootstrap Kubernetes node. So this happens in a typical cluster API provider. So what is the difference with BYOH is that the hardware in the OS is user managed in the sense that the customer or the user is responsible for installing OS, any security updates to it, the customer or the user has to manage it. And what BYOH provider and the CAPI controllers do here is installing relevant Kubernetes binaries. And then we also use the kubeadm bootstrap provider. So we use kubeadm to bootstrap the Kubernetes node. So this is the basic difference between the rest of the providers and BYOH, that we are taking care of only the top two layers in this diagram. I think another notable point is that with BYOH, we are deviating from the machine immutable concept in CAPI, as in suppose say you want to scale up or scale down clusters. Since the hardware is not under our control, we don't have the ability to create hardware or discard hardware on the fly. Like if we want to scale down or delete a cluster, we will not delete the hardware per se, but we will try to deprovision the Kubernetes node. That is, whatever Kubernetes binaries that we have installed, we try to do a clean uninstall. So it kind of breaks down this entire stack into host provisioning and node provisioning. So the host provisioning part is handled by the user, whereas BYOH will do the node provisioning part of it. This is a very high level architecture diagram. This horizontal line indicates the management cluster is in data center and workload clusters are, it could be potentially data center or edge locations like retail store outlets. BYOH in its current form has this limitation that we cannot provision a management cluster out of BYO hosts. That's why we kind of have this as a prerequisite that the management cluster has to be one of vSphere, AWS, or Azure. And on this management cluster, we will install BYOH provider as well. And on the BYOH side, that is at the edge location, on each of the user host, we have developed this new component called the host agent. So this is nothing but a Golang binary. So you start this binary on each of the hosts, and its main responsibility is to communicate back to the management cluster and register this host as available capacity. So all the user has to do is run this host agent, and the host agent will register the host into the capacity pool. So next time, whenever there's a cluster creation request, suppose say to create a BYH workload cluster with one control plane node and one worker node, Cluster API creates all the machine deployment, machine templates, and we have defined similar CRDs like BYO machine templates and BYO machines. So these BYO machines look for, are there any available hosts that it can attach to? Because it is not something like it can create a VM or create a EC2 machine. It has to look for the available hosts that are registered. If there are available hosts, it gets attached to this. Once this attachment is done, host agent can move forward with Kubernetes provisioning, like it installs kubeadm, kubelet, kubectl, even container runtime like containerd, and then uses kubeadm to bootstrap into a Kubernetes node. Suppose say you want to scale up further, say you want to scale to 3 worker nodes, but if you had registered only 2 worker nodes, obviously the third BYO machine is just going to be hanging in there. It is going to get stuck in a provisioning or a pending state. So as long as you have enough hosts on your edge location or the customer site, you can create as many workload clusters as you wish to. So this is the basic high level architecture. I do have a short demo. I'm going to walk you through it. Okay. So like I said, we do need a management cluster on one of the existing providers. For the demo, I'm using a kind cluster.
We can still see
your presentation. You
yeah.
might want to share that.
Oh, you're not seeing this. Okay. Yeah. I thought I was sharing the full screen. Okay, let me stop and start again. That might help. Now you see it, right? Okay. Yeah. Okay, so we are creating a kind management cluster here, and then we are installing the BYH infrastructure provider. So the BYH controller is being installed in the BYH system namespace. Yeah. So for this demo, to simulate the BYO host, we are using Docker containers as hosts. When I talked about the host agent installing all the Kubernetes binaries, we have a component called the installer that does all the installation and uninstallation for us. At the moment, we have some difficulty in making this installer work with Docker containers. So for this demo, I'm using a container that already has all the Kubernetes binaries on it. Yeah, it is this Docker file. If you see this, it's Ubuntu 20.04. We are installing containerd and kubeadm, kubelet, all of it. So ideally, if we were to do this with, say, vSphere VMs, then the installer would have installed all the Kubernetes binaries for us. So I'm creating 4 hosts here based on the Docker image. So this is the host agent binary that we'll have to run on every host. So in the architecture diagram, I spoke about how the agent talks to the management cluster. So right now we have a very nice solution for it. We are using the kubeconfig to reach to the management cluster. So this is doing a bunch of sed commands to include the control plane IP. We will copy over the binary and the kubeconfig to the host. So on all of these hosts, we are going to start the host agent, and we are providing kubeconfig as an argument. Let's look at one of these hosts and look at the logs that are being published. So if you see here, we started the host agent. This registers itself as a BYO host. This network info is basically, we use kubevip for load balancing or for our control plane IP. So when I say add network info, it is basically detecting what is the default network interface so that kubevip can get attached to it. It starts the controllers, and then you see this machine ref not yet set. So it means this has registered itself as an available capacity, but no machine has claimed this host. So it's just lying there and just waiting for something to happen. Now we'll go back and apply the cluster template. Okay, before that, if we get BYO host, we see that all 4 hosts have registered. We have the cluster.ctl generate command to create the cluster YAML for us, and now we are going to apply this template. So the control plane node will start provisioning. So at the moment, we don't have the capability to select any particular host for provisioning control plane or worker nodes. So whatever hosts have been registered, we will just pick one of them to be control plane node, and remaining are going to be worker nodes. So here if you see, okay, we were in machine ref not yet set state, and now we are coming to cleaning up kubeadm directories, bootstrapping Kate's node. So bootstrapping Kate's node is basically executing the kubeadm command, and the remaining hosts are still in machine ref not yet set state. And this one has successfully bootstrapped. So we see the provider ID of the machine as well. Now very soon, the remaining 3 worker nodes will go into the provisioning state. So if we go back, we can see that they've all gone into bootstrapping Kate's node and then finally successfully bootstrapped. So if we examine the logs of, say, control plane host and the worker host, there's literally no difference because we are not differentiating any host to be in particular to be control plane or worker node. So all of them have provider IDs. I think the only bit left is to apply a CNI to it. This will get the kubeconfig of workload cluster first, and then apply CNI. These are the nodes, so shortly they should get into ready state. So yeah, basically this is all I have for the demo. I do have a couple more slides left. I'm going to finish that real quick.
Thanks, Anusha. Does anyone have any questions?
Yeah.
All right. We do have 2 other demos left, so if you want to wrap up your slides, go for it. But let's try to.
Okay. Yeah. So over here. So what's next for BYH? Like we saw, we were using kubeconfig for talking to management cluster, which is very naive. So we want to move to more secure API and agent authentication mechanisms. We want to be able to provision management cluster out of BYH and not rely on other infrastructure providers for that. And we also want to extend BYH to edge sites. So what this means is usually edge locations are with the constrained resources use case. So we want to see if we can reduce the host agent binary size, or how we can make BYH work with other Kubernetes distributions that are more suitable for edge use cases. So yeah, if you like this demo, or if you like this provider, and even if you don't like this provider, do get in touch with us. So we just went open source last month. So we are under VMware Tanzu as of now. So you can, and we don't have upstream Slack yet. So you can reach out to us, to me, Dhamjit, or Jamie in either Cluster API or Cluster API bare metal channels. Yeah, we'll be happy to hear from you. Thank you.
Thanks, Anusha. Thanks for the demo. Anyone have any questions? All right, awesome. If not, Stefan, do you want to just directly go into sharing, since I know you have a demo as well?
Yep, I'll just share. Do you see IntelliJ with some YAMLs which look like cluster class?
Yes.
Okay, perfect. Okay, so I start with a short status update, and then I just show some YAML. It shouldn't take too long. So status update about cluster class patch implementation. Essentially, we got most of our PRs merged. So when you pick up cluster API from main and enable cluster topology, it should work. We have a little bit of work left regarding validation, but it's only if you update cluster classes that it's safe if you change variable schemas and things like that. Huge shout out to Killian to implementing all that validation and defaulting stuff. It was a lot of work and even more unit testing. So great work there. Next hint, I'm not sure if someone noticed, but we already have 4 end-to-end tests running on the core repository, and they're also usable by providers. So we have the usual quick start end-to-end test, we have a Kubernetes upgrade test, we have cluster class changes. That tests essentially that changes to the cluster class are rolled out and that cluster class rebases work. And we even have a self-hosted test, which tests if cluster class is able to run in a self-hosted management cluster. Yep, that should be it. One additional hint. AWS also already has a quick start cluster class test. So please start adopting if possible, and come back with feedback and questions if there are some problems. Short outlook, the next features which are coming up are essentially extending the work on patches to be able to have optional patches, so that patches are not always applied, but depending on some variables, and extending the variable schemas. Currently, we only support basic types, Boolean, integer, strings, and stuff, and that work will make it possible to also use arrays and objects. Yeah, so and now to some YAML. I essentially showed a cluster API provider AWS quick start end-to-end test YAMLs, and just to give a short glimpse on how the cluster class looks like and how we can use that stuff. So first up on the left side is the cluster class. That's essentially just all the stuff we already know. In addition, we have now some variables. In that case, we have a variable for the image repository, which is probably a little bit bigger. Kate's GCRIO. And we added 2 additional variables to be able to control which etcd image. And oh, sorry, that was actually the wrong one. Yeah, that is the AWS demo. Oops. Okay, so back to AWS. So in the AWS case, I just replicated what regular quick start does. So we have a variable for the region, one for the SSH key name, control plane machine types, and worker machine types. So just a very minimal set of variables. And we have patches accordingly. So just one example, to actually use the region variable, I have a patch. The patch patches the AWS cluster template, and it patches the region field according to the variable. When we look at the corresponding cluster template, we see the list of variables, and yeah, just key value. In a cluster template, that's still just the env subst thing, because when clusterctl creates a cluster with cluster class, it still does the same local env substitution to set those fields. But of course, later, if you just create a cluster manually, you just fill in the value. So when we look at how those objects look at runtime, I start with the cluster resource. We essentially see that we now have real values in the variables. So we have a region, EU in my case, and SH key name and instance types. When we look at how that is applied, I take a look at yeah, let's start with the AWS cluster. I think it's very verbose, but let's see if I want to patch the region. So we should see the correct region here, or maybe more interesting, and I also show a variable change is the AWS machine template, which is used. So in that case, we have the control plane template, and we chose, it's somewhere up there in the log, but we set that SH key name as on a cluster, and we set that instance type. So that's essentially how it is resolved. So during reconciliation, we take those variables, we take those patches, and when we create the objects of the managed topology, we just apply the patches on top and fill out all those things. When we now want to change the variable, we can just edit the cluster, for example, and go to, what was the name? Worker machine type. Go to worker machine type, change that here to T4 large. And what we should hopefully see is that we will get a new machine with T4 large. And when we would take a look at the machine deployment and the linked AWS machine template, you would see that it now has T4.large. Yeah, so that's essentially how the AWS Quick Start works. One additional example, what we can do, or what we are validating with capd, if it actually works. A little bit more tricks here. So we have, in this case, two variables which can be used to customize which etcd and which coordinates version are used. Those are usually just properties on the KCP template. And you can still just go into your KCP template and set those variables if you want. But if you want to make them, let's say, more easily user-facing, you can introduce variables here. And on a cluster resource, you can either just set them empty. That means that the default value is used, the kubeadm default value, or you can pick whatever etcd version you want, of course, and that is applied. One additional thing, I think that was maybe use case in the vSphere case. I'm not sure if that's still a problem. But let's say you have a specific Kubernetes version you want to use in your cluster, and you have to find some way where you can calculate properties based on that Kubernetes version. You can do something like this. So what we're doing is, for the Docker machine template, we are creating a patch, and we are generating that patch. And what we do is we set a custom image to kindest node, and then just to the current version we have. So in that case, kindest node v1.22, whatever is used. So that's just, let's say, simple mechanics, simple method to just do a little bit of calculation. And depending on what version your Kubernetes cluster has, or when we change the version, one machine deployment after another is upgraded, your machine deployment will always have the correct version. So that's just calculated on the fly, and don't have to worry about which version is that actually. It's always the same as in the machine deployment. Yep, that was a short version. Any questions? Otherwise, next.
Thank you, Stefan. Yeah, I guess in Azure Provider, we're a bit behind. We had some issues with the Azure cluster template, but we'll give you feedback as soon as we can test it. All right. I think we had another demo next. Yuvraj, do you want to share your screen?
Yeah. Can people see my screen?
Yep.
Okay. Try to keep the demo short. So with the new managed topologies in place and cluster classes in place, we added a new condition called topology reconcile. Now that there is a new step involved when creating a cluster, which is the topology that is defined in the cluster is used to create the underlying objects. We have a condition which reflects the status of that particular step. So it's called topology reconcile. And in most cases, it should be true if everything works, but it goes to false under two cases. One, if there was any reconciliation error, that is while reading while creating the underlying objects, that are in sync with the topology, or while updating the underlying objects to be in sync with the topology. If there are any errors, it surfaces up in the condition. And the other more interesting case when the condition could be false is during cluster upgrades. So within managed topologies, the way a user would upgrade their cluster is just by changing the version in the topology, but that version is not immediately reflected on all the underlying components, like the control plane objects and all the machine deployment objects. Instead, it's rolled out in phases. Like we upgrade the components one at a time. So first the control plane is upgraded. Only after it's stable, we start upgrading one machine deployment at a time. So at this stage, since the underlying object spec and the topology are out of sync, basically the version is not propagated to all of them, the status will be false. And while the status is false, it also shows you helpful messages on why is the status false, or what is it waiting on, or what is being held back, or stuff like that. So we'll take a look at that. So I am going to use Docker provider for this demo. I already have the cluster class and all set up locally. So I'm just going to create a cluster right now. I have a cluster with just like one KCP node and two machine deployments, each with one replica. The version is going to be 121.2. So the initial cluster version is going to be 121.2. And you can see that the topology reconciled is true. It means that the underlying object's desired spec is in sync with the topology, and it doesn't necessarily talk about the status. It just talks about the spec. Are the objects created with the desired spec? That is reflected in the topology. Now let's edit the cluster. So let me change the version to 122.0. And you can see that since the version change is not immediately propagated to the underlying objects, because topology reconciler waits for the components to be stable before it propagates the update, we can see that the status is false. And we can also see a helpful message saying control plane upgrade to 122.0 is on hold because the control plane is still in the process of finishing the initial provisioning, and so on. So similarly, once the control plane is provisioned, if we still keep the update on hold because let's say the machine deployments are rolling out, the message would again reflect that, okay, upgrade to so-and-so part is on hold because machine deployments are rolling out and so on. And we also have like appropriate reasons to against the condition. So there are three kinds of reasons that we can have when the condition is false. One is topology reconciliation error. The other is control plane upgrade pending. And the last one is machine deployments upgrade pending. So under any of these cases, the condition would be false, but in all of the cases, the condition should be true. It's a pretty quick demo. And if we want, we can see that now that the control plane is stable, but we're still waiting for like the machine deployments to finish rolling out before we pick up the update. The message has been like updated to show that we're still holding out the 122.0 update because we were waiting for the machine deployments to finish rollout and so on. So that's the new topology reconciled condition that we have on our cluster objects. There is a PR open for that, and I've already linked it in our meeting notes. So if people want to take a look at it and review it, that would be great. But that's the end of the demo. Are there any questions I can answer?
Thanks, Yuvraj. I actually have a question. Is there any cases where you would foresee someone wanting to force the upgrade, like even if the cluster is not stable? Let's say that some version of Kubernetes is causing an error on the machine deployments and you want to upgrade to the version with the fix.
In that case, like I would say delete and recreate would just force the upgrade. But right now, we don't have a way to force the upgrade if we want to, but that is a good suggestion. We should probably work on, provide a way to do it, because right now they can't force it. It just has to roll out on the way it is. Yeah. And also one thing that I should maybe mention is it's unrelated to the topology conditions, but we don't allow downgrades. So like the versions can only go one way. So if there is ever a problem in like rolling to the next version, we can't roll back. We only need to like jump on a version ahead. Maybe that we're blocking that right now at like the webhook level. So if you provide a version that's older than the version that's already defined in the spec, we do block the update.
Sounds good. Any questions for you, Brash? All right. If not, I will take over screen sharing again. And the next topic is Mateusz.
Hi, everyone. Yeah, so I wanted to ask about the Ignition PR we've been working on for a while now. Wanted to post an update and see what are the next proposed steps. So yeah, we have all the conversation resolved, which yeah, it was a lot. There's like 500 items on the PR. I think the CI is passing. So Johannes had some issues with some end-to-end tests, but I think this is now resolved. And I also heard the announcement about the RC release of 1.1, and I was wondering if you think this could make it into this release, maybe. Yeah, and just pretty much call for attention and maybe have some final reviews. Yeah, for it.
Do we have anyone here who's been reviewing the PR? I don't have the latest information.
So I think since the last feedback, we've added the missing, so there was the end-to-end test, but that was some time ago. And I think the last additions are the documentation. And I'm not sure if this has been like thoroughly reviewed yet.
Stefan?
Yeah, I did a full review a while ago. I didn't have time yet to take another look. I'll try to do that hopefully in the next week or something. I think apart from that, as far as I could see, the major issues that were raised should be solved. So I agree with that in general. And I think my point, or the points that I had in my review weren't that major. So there's probably just another round of nitpicking or something, which I would expect. But yeah, I'm not sure if others will raise some new major points there. That I think that could be what might block it.
Yeah, I think to answer your question, it sounds like it's just waiting for reviewers, which like it is a huge PR with lots of activity and comments. So I think it's hard to follow, takes a bit of time to review. So I think people just need to carve out some time and do another round of review. But yeah, let's aim to have it merged by mid of December. We have 2 weeks. I mean, if there are no major blockers, it should be doable. But yeah, again, just patience and time at this point.
Yeah, thanks a lot. So yeah, we're like as a whole team, we're trying to address the feedback as soon as it comes to don't get things stalled. So yeah, would really appreciate another round of reviews. Thanks.
Awesome. If you could just like tag the people who have been, putting comments so that they can have a chance to check that their comments were resolved, that would be great.
All right, yeah, we'll do. Thanks.
Cool. Stefan, did you still want to say something, or was this your, okay. Cool. Chang, you have the next one, or in the last one actually.
Yeah, so just to have some updates from the keyboard provider side, that we kicked off the first meetings on that keyboard providers with the Red Hat and the Microsoft yesterday morning, and we plan to have recurrent meetings every Monday to bootstrap the projects. And currently, like we are more focused on getting the CI working, because like to test the KubeVirt, we need the nested virtualizations and need the test infra to build on the bare metals. And we made an agreement with the KubeVirt community that part of our CI job will run on their infrastructure, because like the technical stack is very similar, and we will first collaborate on the testing infra first on this project. And I'll share the like once Fabio help us to set up the calendar event. We'll share in the Slack channel for everyone if you have interest to join. Yeah, that's it. Thanks.
Thanks for the update. Any questions about the KubeVirt provider? All right. How do folks join your meeting if they're interested? Is there an invitation or?
So we are trying to set up a kind of like yesterday. I used my personal Zoom, and we are trying to set up a community one, and also post this on the Kubernetes on the event calendars so that everyone can get access to.
Okay.
Yep.
Sounds great. All right. If there are no other questions, I don't see any hands raised or any last minute topics. I think, oh, Fabrizio, go for it. You're muted.
I want just to say thank you for the demo and for the participation for the provider, from the different providers and from new teams joining Cluster API. This is always exciting. Thank you, everyone.
Yeah, thanks for all the great demos, everyone. And we'll see you next week and talk on Slack in the meantime. Bye, everyone.
Thanks, folks. Bye.